Student, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Actually, for E division, as Leena ma'am is having supervision, so I will take this lecture. Let me share the screen. Okay, I hope my screen is shared for both the divisions. Division E.
Yes, ma'am.
Okay, so in last lecture we have completed some of the method to calculate the error. See, in learning or training the neural network, as we said, some of the points are very much important, in which we are considering the method of calculating the error, that is our loss function, which matters a lot. So how to calculate that loss? We have seen in the previous lecture by different methods. It may be MAE, MSE, RMSE, and with that some other methods too. Cross entropy, which is combination of MAE and MSE. If you observe, you can find out some other methods too. But these are some important methods which we are always using. The second point, as I said, it was learning rate. But as I said, learning rate, we are not giving too much stress because MATLAB always giving you different options. Where just by considering different values, you can check what will be the output, and according to that, you can consider the learning rate. Just wait for a minute. Sorry, let us continue. So learning rate, and the third thing, actually, this is weight initialization. So in previous example, we have seen we are initializing the weight to 000. But see, if you are initializing the weight 000, what will happen? That if weight it is initialized to 000, what will happen? Your whatever the speed is there, the learning rate, it will be very small. So we are avoiding that initializing weight 000 for the next problems. Okay, so what we should consider when we are initializing the weight. In last lecture also, in short, I have explained you what we are doing exactly. Yeah. Just give me 1 minute. कनेक्ट होता है नाही ठेवतात ना कमी करणार आहे एक काम करते का आपल्या डिपार्टमेंटचं घेऊन येते काय लॅपटॉप नाही फक्त लॅपटॉप Okay, I am having some issue with my Vacom, but let it be. See, weight initialization is what we are doing exactly here. Instead of 000, we are giving some other values to weight. Maybe it is 0.01, maybe it is 0.003, likewise. So, what values we should give? So, for that, a particular range we are deciding. Maybe it is like -1 to 1, or it may be -0.03 to 0.03, whatever the range. I'm telling you borders of these intervals. So how to decide that lower and upper limit for that intervals? That we are deciding by some particular rules, because directly we cannot decide the values. So when we are initializing the weight, we should consider some of the point, like weight should be small. Second, weight should not be same, and weight should have good variance. So weight should be small means what? If you remember the previous problems of back propagation, the values for weights are very small, like 0.003 and so on. Our next point, it is actually gradient descent, that algorithms we are using to optimize that loss function. So in that we will see what will happen if the weights are very large or very very small. Fitting the curve, this is our main aim actually. So optimized solution we are trying to give. So according to that, weight should be not very big, or it should be not very very small. So what values we should consider for weight, like 0.03, that will be okay. 0.32, that will be okay. नहीं ईश्वरला किंवा किरणला ते लोक नाही आहेत तिथे नाही आहेत का अरे फोन नंबर आहे नाही तो जातोच आहे सारखं गणेश सरांचा पण बघितला गणेश सरांकडे राहुल सरांनी विचारलं राहुल सरांचा शाजी यूज करते ते काल व्यवस्थित झालं आहे काहीच कोणाकडेच नाही अश्विनीकडे आणि अश्विनीचंच आहे Sorry, let us continue. So we are initializing the weights in some interval. So what should be that interval? So for that intervals, we are finding that boundaries by using some particular rules. Three things we are considering: weight should be very small. Weight should be small. Weight should not be same like 0.01. You are not giving this weight to more than one weights. Like there are total six weight. If you consider a simple neural network, student, just give me 5 minutes to resolve the issue. I don't know exactly what is happening.
Ma'am,
Yes, please give me 5 minutes. I don't know exactly what happened. माझा लॅपटॉप हँग झालाय तर मला एक 5 मिनिट द्या फक्त प्लीज. Okay, let's start. So I will repeat just all the points. See, in this unit, as I said, we will try to learn how we are implementing our neural network. So the basic contents we have seen, okay, like what are the contents, what are the hidden layers, what is the activation function, or how we are implementing the different networks. Maybe it is feed forward or back propagation. At the time of back propagation itself, we are using some algorithm that is nothing but the gradient descent. That we will see in detail in this unit. But initially, we are starting with some of the points. I hope I am audible properly. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. So, in this unit, we will start with what care we should take to train our neural network properly. So, we started with the first point, loss function, that are the errors. So, different methods of calculating the error. That's so that the error will be minimum, and we will converge easily to the required things like y and y cap. What are the differences there? Like y cap it is the predicted one, y it is the targeted one. So this should almost approximately equals to each other. So that's why the prediction it will be better one. So in that we have started with the calculation methods for loss, MSE, MAE, RMSE, cross entropy, these are the different methods. The second thing we are trying to understand weight initialization. So if you remember in the starting problem, when we are calculating the new weights, every time we are initializing the old weight as 000. But we will try to understand at the time of gradient descent, like when you are considering 000, what will happen? Our next point. So here, what is the point? We cannot consider the weights as 000 while we are solving the real life problems, because because of this, it will take a lot of time to converge that predicted value to the targeted value. या दोन्ही इक्वल येण्यासाठी आपल्याला खूप जास्त वेळ लागेल. So we are initializing the weight in a different way, like you are giving some random values. You are giving some random values to the weight. A simple neural network, if you are considering, there are total three, or I will consider four inputs. That layer contains three neurons. Finally, one more layer is there, and at the end, I am getting that final output. Okay, so we know that this is connected to every neuron. And finally this is your output. So you are observing there are some weights. Now what I am saying, I cannot consider this all weights as 000. Okay, one time you are doing the feed forward, and as the map, some targeted value is there, some calculated value is there, these two are not equal. There is some error you are finding, and you are starting with the back propagation. Okay, and at that time you are considering some initial weight. So what that weight should be there, so that weight we are trying to initialize here by using some particular intervals. It may be 0.3 minus 0.3 to 0.3, or it may be 0 to minus 0 to 0 to 1. In such an interval, I am randomly choosing the weight. Like here, if you are observing 4 and this 3, 4 is So total 12 weights are there. Okay, W1 to W12. So what value should I give if I am considering this interval? So randomly I am choosing values from this interval. I am choosing randomly some values from this interval. So total 12 weights. And here also again, if you are observing, there are some weights. So 3 into 2, 6. Total 6 weights are here. So total 18 weights. Initialize. We want to initialize total 18 weights from this interval. So randomly these values are selected. Like in 0 to 1, we know that 0.135, this may be one value, 0.269, this may be one value, 0.345, this may be one value. So in a small interval 0 to 1 also, I can find out number of such values. I want such 18 values. So, how we can do this? Is there any rule? Yes, there are some particular rules to decide these values. Randomly, we are choosing this. So, what are the rules? We are starting with the first one. First one is uniform distribution. So, how we are selecting that values? Uniform distribution. Let me tell you, I don't know about the C, but in Python, in our softwares, there is one command, uniform. There is one command, uniform. So uniform means what? The values randomly selected in such an interval, minus a to plus a. Okay, where zero is the middle point. The values are selected. Maybe some of the weights are negative. Maybe some of the weights are positive. So Wij, as I said, I want 18 weights for my previous example. So that 18 weights, Wij, maybe W11. See, I am just writing weights. I am initializing the weight to uniform minus of 1 by Ni to 1 by Ni. Now, what are these notations? We are using notations here. Ni, different notations you can find out. Ni, it is equals to F in, or it is equals to NL, means what? These weights. 1, 2, 3, 4, 5, 6. Total 6 words. These are nothing but NIs. Okay. If I am asking you what is N out, now these notations are NO, F out, and L plus 1 likewise. So what are N out? 1, 2, 3. There are 6 NIs and 3 NOs. So in uniform distribution, how I am finding this range? See, what I said, randomly you're giving or initializing weights in this interval. So I just want this and I just want this. आपल्याला या फक्त काय पाहिजे? Boundary elements पाहिजे. So what should be this element? What should be this element? So it is by using this formula. See the formula? Minus of 1 by Ni. So for the previous example, if I am initializing the weight for the first layer, what will be this? Uniform of. In first layer, how many weights was there? Total 12. So minus of 1 by under root of 12, comma 1 by under root of 12. So from this interval, whatever the values here, minus 1 by under root of 12 and 1 by under root of 12, whatever these values, within this interval, my all weights will be initialized. So this is the first method. See, we need some numbers and there are some methods. This is the first method. This is first method, and the second method is Xavier or Glarot. Both are the names of scientists. Xavier or Glarot distribution. Every time you are having two distribution. One is normal, another is uniform. In normal, what will happen? You are giving a range 0 to A. And in uniform, what will happen? Minus A to A. Okay. So here, what is the formula to calculate this A? It is equals to 0 comma sigma. I hope you remember what is the notation sigma you are using for. Yes, can you tell me in statistics you are using the notation sigma for? You remember the concept of standard deviation?
Yes, ma'am.
Yes. So sigma, it is nothing but the standard deviation. Okay. Sigma we are using for standard deviation. So normal distribution 0 comma sigma, where sigma it is equals to 2 by Ni plus No. Now again for the previous neural network only, I will find out what will be this what will be the interval by using this rule, Xavier's Glarot distribution. This is 0 comma under root of 2 by ni it was 12, and no it was 6. Okay, so the interval it is 0 comma under root of 2 by and 18. Okay, or this is equals to 1 by 9, 0 comma under root of 1 by 9, whatever this number. Now randomly all the weights it will be positive obviously, and all the rates are initialized from this interval, whatever this value. Can any one of you tell me please? 0 comma under root of 1 by 9, what is value of this? Yes please.
0.33.
0.33. Now see, actually if you see the number 0 to 0.33, how many weights I have to initialize? Total 12 weights I have to initialize. इथे आपल्याला टोटल 12 weights initialize करायचे. And again, what we have to remember, that weight should be small, weight should not equal, and weight should have greater variance. Greater variance, last time I told you, greater variance means what? Dispersion should be there. Dispersion should be there. Like you should not consider dispersion means variations असायला पाहिजे त्याच्यामध्ये. Even the interval it is very small, 0.033. 0 to 0.33. In this also, you know, number of values I can consider. So if the interval it is so small, how you can consider the values? 0.3124, 0.3296, 0.3354. Likewise, so such 12 values will be initialized to that all 12 weights. Okay, so this is the given boundaries by using the Xavier's normal distribution. Now let me tell you when, in which particular situation we are using the Xavier's Glara distribution. Whenever your activation function it is sigmoid, sigmoid, as well as I will say tan h. So in both the cases we are using Xavier's Glara, both. It may be normal or it may be uniform distribution. So for normal, this is the formula. Now as I said, uniform साठी काय होणार आहे? For uniform such interval I want, so I want this minus a plus a. So what is the formula we are using here? This is equals to minus of root 6 by ni plus no. Means what I will get? Minus of root 6 divided by ni plus no. So 12 plus 6, 12 plus 6 it is equals to 18, comma under root of 6 by 18. So these are the boundaries. These are the boundaries, and from this interval only randomly. See, try to understand. This is one of the command. ही ना एक command असणार आहे when we are using the MATLAB. Uniformly, normally this will choose uniform or normal. Randomly it will select some of the values like this: 0.3124, 0.3296, and so on. Like in the previous lecture I have given you the example. From your class of 65, randomly I am choosing 10 students without any criteria, whether I want boys, whether I want girls, whether I want academically very strong, whether I want defaulters, nothing. I am not giving any criteria. Randomly I am selecting some of the values. So same thing it is done while I am giving this command. So now from this interval, okay, from minus 6 by root 18, 0 will be there, to plus root 6 by 18. From this small interval, all 12 weights will be initialized. See, maybe you are having a question whether this all the processes are manual. No, definitely you are giving some values, you are applying which distribution you want to initialize the weight. According to that, software automatically initialize that weights. But you should understand how that weights are initialized. That's why we are explaining you all these things. So this is particularly for sigmoid as well as tan h function, Xavier's normal as well as uniform. The notes already shared on your Google Classroom also. This is the last one, he init, or he intake. Actually this is a very complicated name, so short form we are using always he init technique. So again I need the interval, again we need the interval. Now when we are using this, we are using whenever your activation function, it is a ReLU function. Okay, how we are finding? By using normal distribution and by again using uniform distribution. You are observing little bit changes are there in the formula. बाकी काही विशेष नहीं है. According to the activation function, what is activation function? What are their outputs? According to that, we are choosing this formulas. So again, if you see, by using for the previous neural network, what interval I will get? 0 to sigma. And what is the value for sigma? It is equals to under root of 2 by ni. Under root of 2 by ni, it is equals to again 12. Ni it is equals to 12. Okay, so 2 by 12, that is 1 by 6. I am getting all my weights in a range of 0 to 1 under root of 1 by 6. Or by using the uniform distribution, how I will get? I will get it by minus of root 6 by ni, that is 12, comma root 6 by 12. If you compare with the previous one, here the interval it was 0 to under root of 2 by 18, and this interval it was minus 6 to 18 and comma root 6 by 18. Such interval are there. Little bit changes are there. Okay, so instead of, if my question is initialize the weight, so randomly how to choose? So there should be some rule, and these are nothing but these three rules. One is uniform distribution, second it is this he init technique, and third it is that Xavier's or Glarot technique to initialize the weight. So these three techniques we are using to initialize the weight. I am just giving you a simple example. Okay, I'm giving you a simple example. Please tell me what will be the interval to initialize the weight for the given neural network. I'm considering a simple network. There are, I will consider, okay, three inputs. This layer contains three neurons. So weights you are observing. Finally, I am getting the output here as y. Okay, now I want to initialize this weights. मला या weights ला values द्यायचे. I want to initialize this weight. So everyone, please tell me what will be the weights, or what interval should I use by using uniform distribution. What it was? It was minus 1 by root ni, comma 1 by root ni. Okay, this is by first. So please find out this range. The second it was Xavier's, where we are using both. One is uniform and other it is normal. Uniform, you are using the formula. It is root 6 by under root, sorry, ni plus no, root 6 by ni plus no. And here it is 0 comma sigma, where sigma it is equals to root 2 by ni plus no. In statistics, always the number represent some important relation. Like if you remember skewness of kurtosis 3, a number 3 we are using. This is representing distance from 0. So here also that 6, 6 or 2 having one important. Okay, and that's why the numbers are selected such that. So I'm waiting for you. One more it is remaining, and by using this formula, I hope you can tell me what will be the intervals for he int also. He int साठी पण intervals काय असतील, that you can tell me. So please tell me what is this interval. For weight initialization, what will be the interval by using uniform distribution? Yes, I want to initialize this weights. So please tell me this.
minus 0.2886 to 0.2886.
Minus 0.8.
2886. 886.
Okay, 2 plus
Ma'am,
0.
2886. 2886.
Okay, I will just write down 0.2886
8 6.
Okay, so 0.2886. This is the interval in which I have to initialize the weight. How many weights are here? Ni. What is the value for Ni?
12.
Yes. The value for Ni is equals to 12. Okay, so in similar way, please tell me the range for uniform and normal for Xavier's. Yes, what is Ni here? Ni it is again 12 and No it is equals to. Yes,
3.
what is the word? 3. Whether all other students are preparing for the IE or concentrating here, I hope all are attentive. Okay, so I will assume that you are attentive and you can just put the values here. Ni and No, it will gives you the range by uniform distribution for Xavier's and Clollards as well as by normal for 0 comma sigma. A small change is there for he in, no? And what is that change? So that here you are using only under root of 2 by ni. If you see the formula for he int, only you are using this under root of 2 by ni, and here also instead of no you are only using ni. So this is the simple concept actually. See, optimization, it is the main motto for training a neural network. Some factors we are using, that factors are considering the correct method of loss function calculation. Second thing, initializing the weight properly so that we can converge to the desired output in less steps. Third thing, now that is choosing a correct algorithm. Okay, we are calling it as the optimizer also. Correct optimizers we are using. So optimizing algorithms, actually this is the third important concept which is very important to train your neural network in a correct direction, so that in very less iterations you will get your desired output, or you can at least converge. I will not say a targeted value it is 1.32 and you are getting also 1.32. This is impossible in practical examples. We are trying to converge to this value. या व्हॅल्यूच्या नियरबाय आपण जाण्याचा प्रयत्न करतोय. So these three things are very much important for us. Choosing the correct optimizer algorithm, this is also very much important point. So that point you will see in our next lecture. Next lecture चा आपला हा point असणार आहे. Let me just talk with you about your internal evaluation. Already I hope Lina ma'am also told you about the same. I think as per your timetable 11th it is showing your date of internal evaluation. If we are able to complete our second unit syllabus before Saturday, because we are having two more lectures, as I'm saying you, there are different optimizer algorithms, gradient descent. I hope you are learning this name number of times. Gradient descent, del E by del W. Trying to minimize this gradient descent, stochastic gradient descent, then batch-wise gradient descent, mini batch-wise gradient descent, and there are some others too. Adam, Adelta, different algorithms. We will see which are theoretically we are trying to explain you. First gradient descent in detail we will explain you. Remaining four are exactly similar, only some little bit pattern changes will be there. Okay, and after that the remaining one, according to your activation function, according to your data available, we are choosing the required algorithms. Okay, so we will see in our next lecture that optimizer algorithm, and two more algorithms we will see. which we are using for back propagation, particularly Hoffield and one more. So let us see if we are able to complete all this, because within one lecture we are completing all the optimizer algorithm, where and which algorithm should we use, that we will discuss. Half field mathematical we are trying to explain you. So if we are able to complete our syllabus up to Friday, then definitely on 11th we will take test on internal evaluation in our regular lecture as explained earlier, or maybe on Thursday or Friday. But until and unless we are getting that satisfaction, we will not take your test. I think this is your first test, internal evaluation. See, let me just share my experience for first year. We are having, means it is really very shocking that students are taking a lot of tension for offline examination, subjective. So this is my request to all of you. Please be attentive. Maybe it is offline lecture or it is an online lecture, because I know that I don't know how many of you are attending now, attentive in this lecture. But whenever you will revise notes we are providing, definitely today itself I will share the notes for the next lecture, so that at least you can go through it. You are busy in your internal evaluations, but still at least give one look. Other subjects are also new, but this is totally new concept for you. So this is a request to all the students, please, everyone, take care uh, of all the subjects. Current तुम्हाला खूप डिफिकल्ट जाणार आहे, अँड टुडे यू आर गोइंग टू फेस युअर फर्स्ट एक्झाम. सो इफ यू आर टेकिंग इट लिटल बिट सिरियसली, नक्कीच डिफिकल्ट असणार आहे. पण जर थोडंसं लाईटली घेतलं तुम्ही, की न लिहिता तुम्ही एक्झामला जाणार असाल, then it will be really very difficult. So for today's exam also, wish you best luck to all of you. Give your exam properly. If you are having any doubt, we will revise all the concepts one more time, because in the next week we are sharing all the video lectures for unit number 3. So next unit also we are using only for unit number 2 and revision for unit number 1. Okay, as I said last lecture, please put your roll numbers, particularly neural network division roll numbers, in chat box. Today we'll conclude here, but if you are having doubts, definitely we will take the points one more time.